A wire 80 cm long is cut into two pieces. One piece is bent to form a square of side x centimeters, and the other piece is bent to form a circle of radius r centimeter. The total area of the square and the circle is a centimeter square, and in the first part of the question, I need to show that the area is equal to pi plus 4x square minus 160x plus 1600 and whole divided by pi. So what this question is saying that there is a wire and the length of the wire is 80 centimeter. So this is 80 centimeter. The wire is cut into two pieces. So this wire is cut into two pieces. This is the first piece and this is the second piece. The first piece of wire is bent to form a square and the second piece of wire is bent to form a circle. This square has sides of length x centimeter and this circle has a radius of r centimeter. It is told that the total area of the square and the circle is a centimeter square. So the total area A is equal to the area of square plus area of circle. And I need to show that the total area is represented by this equation over here. So to show this, first I'll calculate the area of square and the area of circle. The area of square, this square has sides of length x centimeter. The formula for area of square is L square. The length is x, so the area of this square is going to be x squared. Next, for the area of this circle, the formula for area of circle is pi r square. The radius of this circle is r, so the area of this circle is going to be pi r square. So the total area A that we get is x square plus pi r square. But we needed to show that the area is given by this equation. In this equation, area is in terms of x only. There is no variable of r in this equation. So what I need to do over here is that I need to replace this r with x. And there is no relationship of r and x given in the equation. So first I need to form an equation of r in terms of x. Then I'll replace r in this equation and that would give me this equation. So to form a relationship of r and x, I can use the fact that the total length of the wire is 80 centimeter. I can say that the total length 80 is equal to the length of the first wire plus the length of the second wire. This is the first wire and this is the second wire. This has length L2 and this has length L1. Now to find L1, length 1, I can take the perimeter of this square. Each side has length x, so the perimeter of this square is going to be 4x. So I can say that length 1 is 4x. Now for the perimeter of this circle, the perimeter of a circle is its circumference and the formula for circumference of circle is 2 pi r. So I can say that L2 is equal to 2 pi r. So this gives me the equation of 80 is equal to 4x plus 2 pi r. I need to make an equation of r in terms of x. So I'll make r the subject over here and that would give me r is equal to 80 minus 4x divided by 2 pi. So this is the equation of r in terms of x. Now I'm going to replace this r in this equation. So the area that I'll get would be equal to x square plus pi times r square. So 80 minus 4x divided by 2 pi whole squared. I'll take this power of 2 inside the bracket and it would become the power of the numerator and the denominator. So it would be x square plus pi times 80 minus 4x whole squared divided by 2 pi whole squared. Now 2 pi whole square is 4 pi square, so the area would be equal to x square plus pi divided by 4 pi square, and to expand the numerator I'll use the formula of a minus b whole square, which is a square minus 2ab plus b square. So this would be 80 square minus 2 times 80 times 4x plus 4x whole squared. This gives me area is equal to x square plus pi times 80 square, which is 6400, so 6400, 640, so minus 640x, and plus 4x whole squared, so plus 16x squared, divided by 4 pi squared. Pi divided by pi square is pi, and taking LCM would give me area is equal to 4 pi x square plus 6400 minus 640x plus 16x squared, divided by 4 pi. I need to simplify this even further, so I'll need to make some space over here. I need to show the equation in this form. So to simplify this further, I'll take 4 common in the numerator, and that would give me area is equal to 4 times pi x square plus 6400 divided by 4 is 1600, so plus 1600, minus 640 divided by 4 is minus 160, so minus 160x, and 16 divided by 4 is 4, so plus 4x squared, divided by 4 pi. 4 divided by 4 pi is 1 upon pi, and in these two terms, if I take x square common, I'll get area is equal to pi plus 4 x square minus 160x plus 1600 and divided by pi. So this is the answer to the first part. I have shown that the total area can be represented by this equation. In part 2, it is told that given that x and r can vary, find the value of x for which a has a stationary value. So I need to find the value of x for which a has a stationary value, and it is told that x can vary. So I can find dA upon dx, and the value for which a has a stationary value, dA upon dx, is going to be equal to 0. I already have an equation of a in terms of x, so I'll differentiate this equation. The equation is area is equal to pi plus 4 x squared minus 160x plus 1600 divided by pi. Now before differentiating this, I can rewrite this in a simpler form by writing this as pi plus 4 divided by pi x square minus 160 upon pi x and plus 1600 divided by pi. This whole thing is a constant over here. dA upon dx is equal to 2 times pi plus 4 upon pi x and minus 160 upon pi. This whole thing is a constant, so its differentiation is going to be 0. So this is the differentiation of this whole equation. Now for when a has a stationary value, dA upon dx would be 0. So this would be 0 is equal to 2 times pi plus 4 divided by pi x minus 160 upon pi. Multiplying both sides of the equation by pi would give me 0 is equal to 2 times pi plus 4 x minus 160. This equation has only one variable, that is x, so I can solve this equation for x, and I'll get 160 is equal to 2 times pi plus 4 times x. Dividing this equation by 2 would give me 80 is equal to pi plus 4 times x, and this gives me the value of x as 80 divided by pi plus 4. So this is the value of x for which a has a stationary value. This is what I needed to find, the value of x for which a has a stationary value. So this is the answer to part 2. This is the answer to the second part of the question. This question is finished here now, but let's suppose that if another part was asked in this question. Now the question did not ask me to find the nature of the stationary value, to find whether this stationary value is a maximum or a minimum value. But if the question included that part, to do that, I'll need to find the double derivative, meaning I'll need to differentiate this equation again. The double derivative would be d square a divided by dx square is equal to, the derivative of this term would be 2 times pi plus 4 divided by pi. This term is a constant, so its derivative would be 0. And this whole term would be some positive number, meaning it would be greater than 0. And when the double derivative is greater than 0, then the stationary point is a minimum stationary point. So the nature of this point when a has a stationary value is minimum. The question did not ask us this, but if it was asked, this would be the answer.